may be going live
Maybe
in 20 seconds or less. And I'll,
Excellent.
Yep, we're preparing to go live anyway. All right. Hi, everyone. It's Hugo Bown-Anderson here from Coiled, and Matt from Coiled, and Jacob from NVIDIA. Hey, Matt. Hey, Jacob.
Hey.
Great to have you on the show today, Jacob.
Yeah.
Perhaps you could introduce yourself.
Yeah, sure. So my name is Jacob Tomlinson. I work on the RAPIDS team at NVIDIA, which is kind of an open source suite of GPU accelerated tools for doing data science and that kind of stuff, machine learning. One of the tools in that stack of stuff is Dask. And kind of my job within the RAPIDS group is to act as a maintainer on the Dask maintenance team. So I've been contributing to Dask for a few years, but you know, I kind of have been in the core maintainer team for the last year or so. And yeah, I generally just sit around writing Python all day, and hopefully it's useful to folks who are actually trying to do stuff with it.
So
I think it is.
I first met Jacob before you worked in NVIDIA. You worked at the UK Met Office, like the national.
Yeah, that's right.
Can you say a little bit about your work there, or sort of how you came into Dask, maybe?
Yeah, sure. So I worked in this government agency for about 7 years in like a variety of roles. I kind of started in the organization as a sysadmin, and a lot of work with large scale HPC systems, setting up Linux systems, helping folks make use of these machines, right? They would get some kind of grant money. You'd have researchers trying to do research. They would go out and buy a big piece of tin. I would help them set it up and get going with it. And folks used a whole variety of different things to try and make use of these machines. But we ended up starting like an R&D group within the organization to try and like really speed up folks that wanted to find new ways of doing things. This was like a group called the Informatics Lab. And they plucked people from different areas, right? So there were some scientists, there were some developers, they pulled me from the ops side. And then they kind of mushed all of our skills together and got us to like learn from each other and try and kind of build up different things, and then go back into the organization to try and figure out, right, who's struggling to do what and what are people trying to achieve. And like a big theme all the time was you've got folks that are using tools within the PyData stack, and they've also got these nice clusters of machines, but they were kind of not necessarily using them together, right? They would do some cool analysis in Python, they would do some insane modeling in Fortran, and then kind of be jumping back and forth. And I think looking for tools to help folks scale their Python out so that they could kind of shift more and more in that direction led me to discover Dask. I guess I actually remember one of my colleagues, a guy called Phil Elson, invited us to come and sit in one of the conference rooms and watch SciPy talks that from a SciPy that we hadn't been able to get to. And one of the first talks that I watched was you, Matt, and Jim Christ, like introducing Dask. It's probably SciPy 2017, something like that. Doing an update on Dask. And then I remember us all getting very excited about it and started looking into using it. And like the organization maintains a tool called Iris, which is like a very weather and climate and oceanography specific, like multi-dimensional array manipulation tool. And at the core of it originally was NumPy. And then they kind of started looking at scaling out and things. And they ended up like kind of gutting the middle of Iris and putting Dask in there to help scale out this tool so that the users, the scientists, the researchers that were doing interesting weather and climate stuff didn't have like an API change, but they could all of a sudden, they would run it on a cluster and it would go a lot faster than it used to. And so I kind of got involved in helping support that and teaching people and working on the tools and helping people deploy onto the clusters. The whole organization, we started experimenting with things like Kubernetes, and we already had batch scheduling systems and things. So I ended up building tooling around how to get Dask onto that infrastructure, and that kind of grew into some of the libraries that you find in Dask these days.
Turns out that getting Dask onto infrastructure is a good job to have these days.
Yeah.
And so for everyone just joining, that was at the UK Met Office.
That's it. Yeah.
And for anyone just joining, please introduce yourself in the chat. Let us know what you're interested in, what you're up to, why you're joining us today. I usually ask Matt to tell us what Dask is, and he, more often than I ask even, will defer to our guest. So I'm going to skip the middleman today. I hope Matt isn't offended at this.
Totally fine. We were actually, Hugo and I were on a podcast like a week or two ago, and I actually got to, someone asked me what Dask was. I got to defer to Hugo, which was a fun.
It was a wild ride, and I didn't get it. I didn't mess it up too much. But it's your turn today, Jacob.
Yeah,
Jacob,
sure. So somebody actually asked me this yesterday, and I feel like I've not explained this for a while. But Dask is a Python library at its core for deferring computation into the future, right? So you take a function call that would normally take a certain amount of time, and you can decorate it in Dask and kind of make it lazy. This is something I used to in my old team at the Met Office. We always used to talk about lazy computation, right? So you kind of defer stuff till later. I want all of these things to happen, but we need them to happen later. Dask allows you to do that with function calls, and then when you chain function calls together, you end up building up a graph of all of these different functions, right? You're calling this one and these ones, and then you call a map, and so maybe you're calling functions multiple times. You end up with this nice big task graph to kind of explain, if I was going to do this computation, this is what I would do. And then you, as the the analyst or the developer or whatever, can choose at which point you want to kind of crystallize that graph and actually get a result out. And different things like plotting your data, you certainly want some information to come through, but maybe if you're looking at subsets of data, you care a lot about building up a big task graph and then shaving bits off it, right? Because they're not necessary for the computation. And Dask is also good at doing that kind of thing. And so that at its core is a really useful technique. It allows you to make use of all of your machine. If you've got like a 6-core processor in your machine and you've kind of deferred all of these function calls till later, Dask can kind of do those in parallel, kind of breaking out of the Python single-threaded paradigm, allow you to call all of these functions in parallel. It does what bits it can in parallel. Sometimes it has to do a reduce and kind of pull things back together, but it kind of handles all of that. And because it's got that at its core, you can then start scaling that out onto multiple machines. And it's like, well, I'm going to now wrangle together a bunch of servers that I have lying around. I'm going to get them all connected together in a Dask cluster. And then when I run my Python code, bits that can be distributed onto the cluster would be sent out. And yeah, it allows you to kind of parallelize and distribute your computation. But if in like the context of weather forecasting and like where I kind of discovered it, one of the more important things that we found from performance reasons was that folks would do things like they would load in a global weather forecast. They would then do some operations on it, some reductions and maybe changing some values and converting to different units. And then they would crop out the section they care about. Like, oh, I'm just trying to do some stuff over Africa. So I'm going to crop out Africa and I'm going to carry on doing some things that I'm going to call plot. And in like a traditional processing paradigm, you're going to load in a global forecast and you're going to do these manipulations over the whole global forecast. And then you're going to crop out a section and then you're going to do some stuff to it. Whereas when you kind of defer all of that to later, Dask allows you to do cool stuff like going through all of that. And then it knows when you're trying to plot just Africa, it knows it doesn't need to do all of those manipulations to the whole world. It can only do that to the regions that are important, and you can kind of prune off sections of the graph. So that's kind of what it does at its core. And then right up at the surface level where you tend to interact with it, it implements a lot of APIs that are familiar to folks. So NumPy, Pandas, scikit-learn, those kind of things. If you're familiar with those libraries, you'll find similar and compatible APIs within Dask that allows you to kind of treat Dask as you would those libraries, but it handles all of this kind of laziness and parallelism under the hood. It's always scary explaining what Dask is in front of Matt, but I hope
I can relate, and I think you covered all the bases there. I do. I don't think I haven't heard the first verb someone used be defer, which I like. This idea of deferral, particularly because that's what we tend to do here on Science Thursdays as well. And in particular, talking about distributing work across a variety of clusters and compute at a variety of different locations, which really leads into what we're here to talk about and look at today. So I just wanted to welcome once again everyone who's joining us. We're here with Jacob Tomlinson, who works at NVIDIA, maintaining libraries like RAPIDS, Dask Kubernetes, and Dask Cloud Provider. And we're going to talk about how distributed Dask clusters communicate, different cluster types, and the variety of different platforms you can spin up your Dask clusters on. So without further ado, maybe we can jump into that, Jacob.
Yeah, sure. I mean, I think what I'm going to do is share my screen so you can kind of see what I'm looking at.
Sounds
So let's
great.
go for
prompt things a little bit while he's doing that. So whenever we have challenges around how do we deploy Dask, how do we handle networking issues, how do we, build CI to build Docker just at the right time, Jacob is the person that the Dask community usually leans on. Jacob has both the software developer sort of skill set and the DevOps system administrator skill set. And so he really sort of embodies a lot of the challenges, not about sort of parallel algorithms, but of actually connecting Dask to physical hardware. And that's, I think, sort of the main focus we're going to be focusing on today.
And one other thing to mention, if we haven't already, you two have worked together at NVIDIA, right?
Yeah, that's right.
Yeah. We stole Jacob away from the Met office to come work at NVIDIA. It was a great time. We still work together, just at different companies.
Yeah, great.
Yeah, it's interesting being part of the Dask maintenance team, right? Because I have a team in NVIDIA, and then I have a team that is the Dask maintainers, which is made up of folks from different organizations. And it's quite nice kind of sitting in a multi-organizational team, as well as a team that I'm employed to be a member of. So yeah, Matt and I are still in that Dask team together. It's just that Matt's no longer in the NVIDIA side of the team. But that's because you're off doing cool stuff at Coiled, right?
Of course.
Okay, so I've got my screen shared now. This is a blog post that I kind of put together earlier in the year to kind of talk through different ways that you can deploy Dask, right? So in my kind of description of what Dask is, I talked a bit, I kind of glossed over the fact that, you can pull multiple machines together, right? And get them, run this Dask cluster, and then your computation runs onto that, right? But getting multiple machines pulled together is one of the tricky parts, right? Of actually getting set up and going on this. I like that Matt mentioned, right, that I have developer skills and the DevOps kind of skill set. And I've been described in the past as a DevOps engineer, but I much prefer to say I'm an ops dev engineer, because I'm more heavily weighted in the ops side, in the kind of deployment side. And I think that's maybe slightly unusual and therefore hopefully useful to projects like Dask. So I'm going to roughly talk through a bit of this blog post, at least just the beginning bit, before we kind of really dig in. And then we're going to actually have a play around with trying to pull some machines together and do some Dask stuff on multiple machines. So when you run Dask as a cluster, there are some, you install the Dask Python library, and you get another package, a sub-package called Dask distributed. And this comes with a couple of tools, a couple of command line utilities that you can use for setting up this cluster and getting it talking to each other. So the first command is Dask scheduler. And this starts a server running on a machine somewhere. And this is the kind of central point that all of your computation, all this graph of calculation will be sent to, and then it will carve that up and send it off to the workers of the cluster, the things that will actually do the computation. If you're familiar with Python, it does this by kind of pickling up information and kind of sending it around between the client, which is kind of where your Python code is running, and the workers, which are the pieces that are executing. So the Dask cluster is kind of the first thing you need in order to getting yourself a Dask cluster, the scheduler. But once you have a scheduler, you need some workers to connect to that. So there's also a Dask worker command line utility, and you run Dask worker, and then you pass it the address that this scheduler is running on. So you can see in this little example here, we've run Dask scheduler, and it says the scheduler is running here at the host name of the machine at port 8786. So then in order to run Dask workers, you run them and tell them where to find that machine. They communicate over TCP. They'll connect to the scheduler, and then they'll just sit waiting for work. And then in your Python session, you need to instantiate a client. So from Dask distributed, you import this client object, and you instantiate this client, and you tell it where the scheduler is as well. So you pass it this same address that we told the workers about, and your Python session will connect through to the cluster. And then once you've kind of created this object somewhere in your Python session, any Dask computation you do will kind of inspect the current environment and see whether one of these clients are there. And if it is, it will kind of hand off all this deferred calculation up to the scheduler. So that's kind of like a basic way of doing things.
That's great, and that makes perfect sense. I do have a question. This is something you can do with a cluster. It also is something you can do on your own workstation for out of core as well.
Yeah, I mean, so you don't necessarily, you can definitely use Dask distributed on your own machine, and it's great for using all the cores in your machine. And all of this kind of stuff, you can run Dask scheduler and connect some workers on your machine, but we actually have some like built-in helpers to kind of set things up for you. I'm going to kind of skip over the dashboard bit. We'll come back to that. But we are going to move on to the cluster managers to just kind of answer that question. So within the distributed library, and also within some of the other kind of, we have like side libraries within Dask, right? So we have Dask and we have distributed, which are like two main repositories on GitHub, but we also have other projects like Dask Kubernetes, Dask Job Queue, Dask Cloud Provider that kind of are more on the periphery of the main project. You install them separately, but they all add things like this, right? So they add what we call a cluster manager, which is a class that does some bootstrapping and setup for you. And the most common one that you often will come across is one called local cluster. So in your Python session, you can do from Dask distributed import local cluster and client. And then if you instantiate local cluster, this will, on your machine, set up a scheduler, have a look at how many cores your machine has, set up some workers to kind of fully utilize that as well as it can, set up like communications between them using sockets, and give you back a cluster object. And then you can pass that directly to the client. So if you're just leveraging one machine, you can set up this way without having to worry about actually starting the individual pieces. But then when you start getting onto multiple machines, you need to worry more about where am I going to put the scheduler? Where am I going to put the workers? How am I going to get them talking to each other? What's what does the deployment mechanism look like? What does the networking look like? All these kind of things. And we have other helpers to do that. But I think we're going to start from basics and have a look at that process in a minute.
And maybe you could just speak to, or maybe you can tell me to shush as well, but these sounds like the type of things that modern data scientists don't necessarily have all the tools to do. There seems like a lot of kind of software and DevOpsy stuff here as well.
Yeah, that's absolutely true. I think it's stuff that's, a lot of it is like a necessary evil at the moment, right? In order to do your data science work, you need to leverage multiple machines. You need to, in order to get any reasonable amount of computation done, you're going to need to be able to pull these resources together. But you shouldn't have to care about how to do it, right? Like, I mean, I come from this background of working with researchers and scientists that care about weather and climate. These are folks with PhDs in physics and environmental sciences and geography and that kind of stuff. And they have to use computers as a tool out of necessity. And they shouldn't really have to care about what's going on. They should be able to care about asking the questions of the data and of the science that they want to do. It was funny actually being in that organization. There was maybe about 600 people that were kind of employed scientists working on things, and then maybe a few hundred people that were employed software developers building tools. But I reckon if you asked of the organization, like, who identifies as a Python programmer, you would probably get maybe 300 or 400 people put their hand up, but that's only half the people who actually sit writing Python all day, every day, right? It's just that these folks don't necessarily identify with being a software developer. It's just a tool to them to do these things. And so a lot of what we try and do in Dask is give them tools that they don't have to worry too much about what's kind of going on, and try to make stuff as easy for them as possible. And supporting like a bunch of different mechanisms. Like if their institution has made an arbitrary decision to use a specific cloud service, or they've bought some specific piece of infrastructure, like it doesn't really matter to the individual researcher. They just know that there's so many cores and so many gigabytes of RAM, and they need to do this calculation that will take this amount of time, and they want to just pull those resources together.
Yeah, that makes sense. And I think it is still challenging sometimes to get, Dask up and running on a variety of cloud providers. Do you know any companies that are working on making it significantly easier for?
I don't know. I've heard that there's some stuff going on in that space, right? Like
Yeah, I think so. So I'm definitely leading the witness there. Well, that's stuff we're working on at Coiled. And I know Matt may push back on this, but if you are interested in this type of stuff and want to get involved in our beta product, which is free, go to coiled.io to test out our product, take it for a test drive, which helps you scale up your Python code as simply as possible on the cloud. Okay, pitch over. Let's keep going.
Get the pitch.
No, it's good.
Jacob's talk, because Jacob's talk will talk about how challenging it is to actually do all of that stuff.
Yeah.
Right. And that's, I think, what I'm really excited about hearing more about is about actually like diving in, starting these things up, playing with on many machines, seeing what comes up, see what the challenges are, and then working around those challenges. And that's like a very educational thing to do that explains why setting up can be challenging, and then why sort of things like Coiled are useful.
Great.
Yeah, definitely. So what I'm going to do is, like, I've kind of skimmed through a bit of this blog post, but I'm going to stop at this point and I'm going to try and set up some machines that I kind of have here. So like so far, I have a laptop that I'm using for this video call. I have Python installed on it, so I'm gonna play around with that. I also have another laptop. I don't know if you can see my webcam, but I have another laptop, which is actually like my personal gaming laptop. But that happens to have Linux and Python and things installed on it. So I'm going to try and just pull these two machines together into a Dask cluster, just so we can see, like, have a look at what that process is like. So let me just swap over to some terminals and actually try and work out kind of what I'm doing and where I'm going. So if I conda activate Dask, I have a conda environment already set up here, which has Dask installed probably at all the master branches, although I might not be fully up to date. This is just because I work on Dask all the time, and I probably have the same on my other machine, right? So if I just SSH over there, which I've got the LAN IP address here.
And Jacob, the screen size is fine, but if you bumped it up maybe one extra notch,
yeah,
you're welcome.
Absolutely. Okay. Yeah, let me try and figure out how to do that.
Or even just like the terminal. Yeah, great.
How's that?
That's good. Thank you.
Just SSH to the right user of that machine. Okay. So yeah, this is a Linux machine. It's running elementary OS, which is just a Ubuntu derivative. But I think I also have a Dask environment here too. Yep. Although this might be slightly out of date. So I have these two conda environments. I might actually not. Yeah, let's actually not do that. Let me install it on this machine, just so that we can kind of see what that process is like. So I'm going to do conda create. Let's call this the coiled stream environment. I'm just going to throw Python and IPython in here for now. I should probably have done conda forge as well. Let's do it from there. That'll be fine.
So it seems like step one to use Dask is first install Dask.
Yeah, that's always a good starting point. I guess, yeah, step 0 would be install Python. But I happen to have Python and conda set up here.
And so on the left, I think we're looking at your laptop. And on the right, upper right, you're looking at this sort of gaming laptop that you've got sitting on the side. Is that, it looks like that's running Linux. So you're not running Windows and Linux, or Windows and Mac's a hybrid.
No, I'm just running Linux. Valve have put that much effort into making games run nicely on Linux. I actually feel like Linux is a viable gaming choice these days.
I just wanted to welcome everyone who's joining. I'm really chuffed that we have people from South Africa. We have someone from Sydney who's tuning in super late. We've got someone from Canada, someone from Colorado, and someone from Bangalore in India as well. So we're representing a lot of the globe, which is really cool.
It's always fun doing stuff like this and seeing folks from all around coming to join.
I had someone join from Antarctica once. I found that
nice,
very surprising. Yeah,
I'm impressed by their bandwidth.
Yeah, exactly.
Yeah. I mean, I assume Antarctica is mostly occupied by scientists, right? And this is Science Thursdays, so
you got it.
Yeah. Okay. So I've got on the left-hand side, I've got my like regular Dask conda environment, which is probably some strange version of Dask. I may come up with another conda environment in a minute. On the right-hand side, I've just created myself a new conda environment with just Python at the moment, but I'm going to conda install Dask next as my first step over here. So there's a bunch of dependencies, but there are also, this is kind of why we have other packages, right? Because if we wanted to include Kubernetes support, or we wanted to include various cloud provider support, they often have their own SDKs and APIs that are kind of useful for bootstrapping those things, but you don't want it to be too heavy in terms of pulling that stuff together.
They also have their own maintainers, their own CI systems. It turns out it's actually hard to find an individual, maybe other than yourself, who knows Kubernetes and Yarn and HPC job schedulers and SSH handling, all those things. And certainly That's a different set of people than people who we know who understand, pandas and machine learning algorithms. So a variety of different, classes of Dask maintainers. I think on this show, we usually have sort of data science folks and, developers. And Jacob is sort of unique in that he spends a lot of his time thinking about system administration. And this is like another very critical role of Dask today. Actually, probably where most of the growth has been in the last year or two. I think probably half of the things that we talk about as a maintainer community right now are really about like, well, how do we figure out deployment on this kind of system? That's been the main interest.
Yeah, I definitely think in institutions, especially, a decision will be made by some folks that probably have a skill set similar to mine in terms of what infrastructure should we buy or who should we pay for some infrastructure. And that decision is often made centrally to try and make sure that you're getting the best value for money and spending your grant, however, the best way that they can. But then you often end up with a large shared resource or some kind of tooling that everybody is kind of pushed into as an organization. Like I said earlier, like folks generally shouldn't have to care, right? They should be able to just use the tool that they want to use. I think one of the things that's great about Dask, and one of the things I like about working on it, is like you say, there's so many different ways of getting set up and getting deployed. If you work for an institution that has a big HPC and it uses PBS to schedule jobs on it, and you can use the Dask job queue scheduler and tooling to use that. And then say you like switch organizations, you leave and you go work somewhere else or do something else. And that institution is more bought into the Hadoop ecosystem and they have, a Yarn-based scheduler. You can just switch Dask library and continue. Your skill set is far more portable because you can just kind of move with wherever you're having to go. You're not having to learn something specific to a specific set of hardware that's been bought kind of on your behalf, right? Okay, so I have installed Dask now, so I should be able to go Python, or let's go IPython, just make things nice. And if I import Dask, spell import correctly, I have Dask over here. And on this side, I'm also going to go Python. I have different Python versions. That's probably going to make things slightly fun. I may make myself a new Conda environment over here as well.
Wait and run into that issue, and then we
okay, that sounds fun.
Experience that issue, and then we fix it.
I love your response was that sounds fun.
Well, this is a pretty common problem, actually, is matching Python versions, matching Dask versions, matching pandas versions. I think that's something that we should run into rather than try to avoid.
Definitely.
Okay, so what I'm going to do...
less sophisticated than yourselves like me, I've run into that problem a great deal, and it definitively does not sound like fun. But I love that for you too. It does.
Well, great.
So I'm going to set up a few more things here. So what I'm going to do is I'm going to have up in my top, I've got 4 windows now, right? I've just split my timeline a few more times. So I've got, I'm just going to try and make things a bit more even, actually, just so it's a bit easier. Let's jump over there. Just to make it clearer. So you might be able to tell from my little icons and things that I've got going on. The top 2 windows are my laptop. That I'm like typing on and speaking to you on, and then the bottom 2 windows are my like other personal laptop that's kind of propped on its side next to me. You can kind of tell that one by the SSH lines. If I conda activate Dask on the top one, and I'm just going to make sure I have conda activate stream on the bottom ones. Okay, so what I want to do is on one of these, I want to start a scheduler. So I might, I think I'm going to start my scheduler on this window down here. So this is on my laptop. So I'm just going to say Dask scheduler.
And maybe for the people who've joined us recently, you could remind us what a scheduler is?
Yeah, sure. So we've there's a blog post on the Dask blog that I wrote a little while ago.
And I've posted it in the chat as well.
Excellent. Yeah, so this is going over the current state of all the different ways you can deploy Dask using the open source tools that are part of the Dask project. And setting up a scheduler allows you to execute your Python code across multiple machines or multiple cores in a machine. In order to set up this cluster, you need a scheduler, which is like the central point that kind of does all the communication, it wrangles everything, it takes in all the tasks that need to be performed, and it dishes those all out to the workers so that they can do the computation and hand the work back. So you have the scheduler, and you can set it up with a dash scheduler command. And that will run like a server on a port on your machine, a bit like setting up a web server. And then you can also set up Dask workers, right? So you have you run the Dask worker command and you tell it where the scheduler service is, and the worker will then connect to that scheduler ready and sit waiting for work. And then in your Python session, you can create a client in your Python code, and you can get that client to also connect to that scheduler, and then that will start kind of sending the work through to the cluster. So over here on my terminal, I've started a Dask scheduler on my gaming laptop. And what I'm going to do also is start a Dask worker on the gaming laptop. So let's do Dask worker. And I'm just going to take this address here. It's just my LAN IP address of the laptop. And I'm going to run that. So the Dask worker should now connect to the scheduler. So you can see on the left-hand side, we've got some information about the worker. On the right-hand side, we can see we've got this register worker line that's popped up. The worker is itself running a little server so that it can receive commands, and the scheduler is kind of connecting back to that. So those two have spoken to each other and started up this connection. The worker over here will have detected how much resource this machine has. So this is it's got a 6-core i7 with hyperthreading. So it's given me 12 CPU cores, and the machine's got 16 gig of RAM. So the worker's kind of found all of that resource, and it will make use of all of that resource. Now, if I up on my actual the laptop that I'm speaking to you on, I could also do the same thing. So I could say Dask worker and pass it the same IP address that we did before. So I'm telling my work laptop to speak to my gaming laptop as a Dask cluster.
And we have a question from Jason Myers in Tennessee. Do we need a worker per core?
So not necessarily. The worker should find things, find all the resources of the machine. I think if you use local cluster, it will set up a few workers to make use of a few cores. Matt, do you know like how that's decided in local cluster?
Yeah, so first the direct answer is no. One Dask worker can have a thread pool locally. So in the lower left terminal, see Jacob has started one worker and it has 12 threads. So so by default, Dask will sort of claim as much of the machine as possible. For different kinds of workloads, we'll want either lots of threads per process or lots of single-threaded processes. It depends if you're like holding onto the GIL or doing text processing or compute processing. Jacob, to answer your question, I think our like general default recommendation, if you don't know what you're going to run, is to choose like the square root of the number of cores that you have. So if you have 16 cores, make 4 processes with 4 threads each. That tends to be an okay metric all the time.
Yeah, interesting. I didn't realize that was the measure actually. I think for both of my laptops, they happen to have 12 threads. And I think I tend to get 3 workers with 4 cores each, something like that.
We're getting four processes with 3 threads each. I think we run.
That makes sense. So yeah, I've tried to connect my work laptop to my gaming laptop, and I'm starting to see some funky exceptions up in the top here.
So Jacob, I think in this case, we know kind of what's wrong, but what might be wrong in this situation? What are like the 3 most common issues where things can't connect?
I like that you said 3 most common issues. You know the 3 answers that you want me to say. I have no idea where.
I think there are 10 answers. I'm just giving. I think you can identify 10 answers too. I'm just
that's true.
By saying list 3.
Yeah, absolutely. Okay, that's fine. If it's a limit of 3, that makes me feel more like I'm not shooting for the right answer. Yeah. So I mean, the first and kind of most obvious one is going to be: can the 2 computers actually talk to each other? Is there networking between the 2 things that allow that to happen? Now, I am actually in an interesting position, I think, because my work laptop is connected to one LAN and my gaming laptop is connected to another LAN, because I'm one of these people that overthinks their home network and has like multiple things going on. So that could be a factor. I think it's probably unlikely. I can plug a cable in to put them on the same LAN to make sure it's not, but making sure that things are on the same network is often a big problem. This comes up a lot in like cloud-based systems. If you deploy some machines onto the cloud and you're trying to access them from your laptop wherever you are, you don't necessarily know whether the communications can be able to go in both directions. Often you can like reach into the cloud, but the cloud can't like reach back to you because you're sat inside a office or residential network that won't let those connections back through. Other things you might find issues with is versions of Python that are kind of out of date with each other, versions of Dask that are out of date with each other. You know, I've kind of intentionally here not thought too much about the Dask installation on my work laptop, and then I've just installed it from scratch on my gaming laptop. So I've probably certainly got very mismatched versions. My work one's probably the master branch of distributed, probably from yesterday, right? So it's slightly, maybe slightly out of date with that. Other things are just going to be whether the package is installed correctly, whether things are kind of able to run correctly.
Great.
So I think what I'm going to do to try and get around this is create a new Conda environment on my work laptop and install Dask in the same way. I think generally, because I've done it like in the last few minutes, I can be pretty sure that I'm going to get the same package versions. What could be even more robust would be from my gaming laptop to output the contents of my Conda environment and move that to the other machine, and then create a Conda environment explicitly from that, so I can be sure that they have the same thing. But I think I'm just going to, for speed, try and just remember the commands I typed in. I'm going to create a new environment. I'm going to call it code stream again, and I'm just going to put Python and IPython on here. We may notice that this install goes slightly faster than the last one, just because this computer is plugged in with a cable and the other one was on Wi-Fi and I'm reasonably far away. But again, I'm doing that intentionally because having things connected to each other as fast and low latency as possible like matters, but also you can pull together various resources that have different connections that may be in different buildings or different rooms and still make good use of them for running your computation. So I've created my Conda environment, I've activated it, and now I'm going to Conda install Dask here as well.
Right. Remember last time we went through this, while you were downloading MKL, I was trying to like fill time by talking about other things. So things did go a bit faster.
Yeah, things may also be cached on this machine just because I use it more for this kind of stuff. Now I'm going to try again. I'm going to run the same Dask worker command from this environment with the new Dask and see whether it manages to connect through.
Not looking good.
It's not, is it? So it's a similar exception.
Yeah, so what's going through your mind right now? What, as you're trying to diagnose this, what are you thinking about what might be wrong and how you can diagnose those things?
So I guess I'm likely thinking, can these things talk to each other? And how can I figure out if they can talk to each other? So the IP address of the work laptop that I'm on is this 100.15 address, and the gaming laptop is this 0.32 address. So I guess initial stuff I would try is from my 100.15 machine, can I at least ping the other one? And it is responding to ping, which is good. And then from the other direction, can I ping back to this machine? So this is the 10.51.100.15 machine. So I can ping back in the other direction as well. So the connections, at least, some requests are going through, ICMP requests are going through. So I would probably start thinking about firewalls now and whether some of these other ports may be closed or having trouble with that. I think what I might do out of curiosity is actually just start IPython. Let me activate the right environment. Conda activate world stream. If I just IPython in here and see whether I can start a client, right? Because that's just another thing that's going to use the same connection mechanism to try and connect through to that scheduler. Try and connect through to here, this laptop here. Oh, this should be a string. Yep.
Looks like that is also stalling.
It does seem to be.
Something I noticed. Oh, I noticed you had Python 3.7 in one environment, Python 3.8 in the other. The mini
yes. I think I have resolved that now. I think I do have 3.8.5 now in both.
Okay.
Because I recreated my Conda environment. Yes, SSH can reverse port for sure. Whether I've actually configured my gaming laptop that I can SSH into it and reverse port, I don't know. But that's something that would be an interesting thing to try. So if I do SSH, it was to that machine. But if I do port forwarding, let's port forward 8786.
So I'm going to narrate what I think you're doing. So I think what you're identifying is that maybe these high ports, 8786, you just keep doing stuff. I'm just going to narrate why you do some work. 8786, 8787, these ports might be too high, and your local router may actually be deciding not to let them through. They look kind of suspicious. And so I think that you're choosing to sneakily send it through a different port with SSH.
I am. That also seems unhappy, which is interesting. Yes, that does also seem unhappy. I'm also going to check the scheduler dashboard. So we haven't talked about the scheduler dashboard yet. I might just jump back to the blog post and kind of talk about it for a second. There's something that having a scheduler gives you is we have this nice dashboard which shows you what tasks are being executed, how much memory is being used by the cluster, how many tasks are processing, what the workers look like, and like other information about the cluster. And so that in the scheduler window down here, we can see it says, the scheduler is here, but the dashboard is at the same address, but with 8787 instead of 8786. So I'm just going to see if I can actually connect through to that, which it does. OK, so high ports must be going through if I'm able to view the dashboard from this machine. We can see my one worker here in the worker tab, the one that we started on the gaming laptop. Oh yeah, I didn't install that. It's fine. Okay. Interesting. I was intentionally going to make this look hard, and then I've managed to make it even harder than it actually is.
So people understand this is when, I mean, keep thinking, Jacob. I'm again going to sort of talk while you do the hard work of actually trying to fix the problem. This is actually what we run into every time we meet a new system. There's some wonky issue with local networking policies, with software versions, et cetera. Launching Dask is usually pretty easy. Like you just need to start some processes and they talk to each other. But actually navigating networks, navigating all this stuff ends up just being a challenge for a lot of sort of unexpected reasons. And going through this process of diagnosing what's going on can be interesting.
And what do you think is going on, Matt? What's the issue?
We don't know. The two most common issues that we run into are either your software versions are mismatched, and Jacob solved that by Conda installing the same commands on both machines. Because like Dask from a year ago probably communicates a little bit differently than Dask from today. And so if the two sides are trying to talk to each other, they may have different protocols. So it's important to have versions match mostly. There can be some flexibility, but not a ton. The next thing we tried was obscure networking policies in Jacob's home network, right? So often, like in corporate environments, often you'll find that, only port 80 and 443 for HTTP and HTTPS are open. And there's no other ports that are open because that looks like suspicious, cyber hacky kind of behavior. A lot of processes that are like Dask that are sending lots of messages at high volume on these random high ports, that looks kind of like people trying to steal things out of your company. And so a lot of sort of corporate networks will lock those down. There are a bunch of other things that can happen. Maybe like Jacob is looking on his Wi-Fi network on one machine and on his wired network on the other machine. So you can get some things mismatched. But in this case, we don't know. And so as Jacob has been doing, he's been doing things like he pings back between all of the machines, make sure they can talk to each other. He's tried using special fancy tricks like SSH tunneling to try to sort of mimic some other behaviors. And then you kind of sort of smash your head against the wall for a while. to until things suddenly work. And you find out it's some bizarre flag that was in, the Etsy hosts file and some machine that's just like is annoying to deal with. One thing we could also try, Jacob, I don't think it'll be necessarily very helpful, but we could switch the relationship of scheduler and worker and try the remote machine to log into your work laptop. And maybe that will tell us something. I don't expect it to, but it's something to try.
Yeah, absolutely. I'm fully expecting this to be some strange thing that I've done with my home network more than anything else. Oh, that's fun.
Pickle protocol. Can you run Python version on your work gaming laptop?
385 on the gaming laptop. 385 on the work laptop.
That's surprising.
Yeah. I did see this actually in a Dask issue earlier. We're like slightly going off onto maybe something is actually broken in Dask, but somebody did raise this.
Why don't we walk backwards in time, maybe to Dask 2.20, and then see if things work there.
So, 2.20, you say?
I mean, yeah, anything a couple versions back. So Jacob and I happen to know there have been some changes to the Dask protocol in the last couple of weeks. And so we're actually going to walk back in time a little bit and see if we can get things running. If we're going to uninstall Dask 2.20 on both machines. Why did that not?
Do I need to do upgrade or something in here?
Maybe 1 equals rather than 2? Great.
Okay. It seemed to work.
It's surprising that it was already. So the as of today, the most recent version of Dask is 2.23. Right? So there's a version mismatch between Dask, which totally explains the problem that we're having. Maybe just uninstall Dask 2.23 on the gaming laptop. Yeah. Right. So somehow, even though Jacob had run the same condet install commands on both machines, we ended up with different Dask versions. And because we had different Dask versions, those two processes couldn't connect to each other. And so we had to be extra special careful and actually check the Dask version manually on both machines to find out there was a mismatch. Now, hopefully things will work out just fine.
Yeah, we've got the right version there now. Yeah. I'm going to start my schedule on my work machine again, and Dask worker up to here. So I think the only other difference between these machines is one is a Mac and one is running Linux. So,
I mean,
did I? Maybe I didn't do distributed as well. Do I need to do that separately to do this?
Sure, could be. Yeah, so I mean, it could be that when Anaconda was building packages, maybe that the Linux package was updated faster than the Mac package. And so even though Jacob ran the same condet install Dask command on both machines, we found that it was actually a mismatch because the architecture was different.
Yep.
Hooray! Starting established connection.
Woohoo!
Okay, so I should be able to do the same if I get a 100.15 here. I didn't mean to do that one, did I? I meant to do this one. Good. Okay. I have both machines connected. So I do wonder if like one thing that may have resolved this would be using the CondaForge channel to install Dask from instead of the defaults, maybe.
Right. CondaForge updates a little bit more quickly than defaults.
Yeah. So I may even have some Conda config on one that I don't have on another that maybe did that. Anyway. Yeah, so now I have a scheduler and I have 2 workers running. I could probably do more sensible things about running multiple workers on each machine, but I'm not going to worry too much about that now. So that should mean that I have 2 machines with 24 cores and 32 gig of RAM shared between them. I can have a look at the dashboard to probably prove that that is true.
We also do some work, right? We can, have not 1 laptop, but 2 laptops connected.
Exactly. So if I have look at my workers, yeah, I have 2 workers. So my total show I've got 24 threads, and my memory limit is 32 gigabytes of memory. So that's great. So if I down here now, if I import Dask, let's do, let's import Dask array as DA and import from Dask.distributed import client. Okay, so we need to create our client first, like we were going through in the blog post. We do client equals client, and then this scheduler address over here. A client object. We saw that in the scheduler as well, saying received client connection, starting established connection. And now I can do something like, my array equals da.random, some big array. So 1,000 by 1,000 by 1,000 just to start off. Now, like this, we're following the NumPy API here with Dask array. So this should feel a lot like NumPy. But one of the things you can do is, if we create a random array that's 1,000 by 1,000 by 1,000, we can specify, I want it in chunks of 100 by 100 by 100. This will make our array, but it will make them into smaller pieces, and those pieces can then be shared between the 2 windows. Yeah, just to answer the question in the chat, this is Tmux, which is just like a terminal manager. I mainly use it because when I SSH into, I use iTerm on my Mac, which I quite like as a terminal environment. On Linux, I tend to use ST, the simple terminal. And so I like Tmux because it gives me like a consistent environment. I can SSH between multiple things, and I get nice window tiles laid out like this. I do also, I'm generally a fan of tiling window managers. I do use i3 on my laptop. I'm not quite one of these people that runs Arch, but I'm nearly one of these people. So let me, so I've made an array. This array is, chunked in these kind of this way. And if I have a look at this array, we can see that this is a Dask array, and we can see this information about it, right? It has the shape and these chunks, and the chunk type underneath is a NumPy array, right? So Dask has created this big group of NumPy arrays, and each one can kind of be worked on and manipulated separately or as a whole as the Dask array. And Dask supports multiple internal array types, so you could, if you wanted to do some GPU computing, which we could do on my gaming laptop, we could use a CuPy array instead of a NumPy array to get some GPU acceleration on that as well. And so you would get GPU acceleration on whatever you're doing to each individual chunk, and then Dask would manage the overall operations between everything. So if I then do something like my array dot mean, we actually just get back a lazy object. This is what I was saying right at the beginning about Dask defers stuff into the future. So if I just call mean on my array, it gives me back another array of, it's giving me a shape of an empty tuple, which just means that it has a shape of 1. The result of this would be a Dask array with a shape of just 1, because it's just the number, which is the mean of this array. But what it's kind of telling me is, if you were to do mean, this is what I would give you. This is a thing, but it's not actually done that. It's just said what it would do if I had asked it to do that. I could assign that to a variable, so I can do things with it later, or I can just run it again and specifically say to it, please do the thing that I asked you to do. And you can do that by calling compute on it here. So if I call compute, things that are happening. And if I come to my dashboard, if I'm fast enough, we should see things happening. There we go. Things are happening. So this was kind of showing all the individual operations. These are all the random sample operations, and the mean, it will do means on each individual chunk, and then it will kind of tree that up and aggregate and do higher level means that you can probably see here. So we get mean combined partials and mean chunks, and each piece is meaned, and then in a MapReduce style way. all the red in here was the network communication between the two machines. So every time some result needed to be passed back and forth in order to get this final answer. So just to give you an idea of my network topology, that would have gone from my work laptop through an Ethernet cable into a switch. It would have then gone through another Ethernet cable up into my attic to another switch, which would then come back down another Ethernet cable, probably into my living room, into a Wi-Fi hub, and then would have come over the Wi-Fi to my other laptop, right? So that's not the most ideal network topology for doing this kind of thing. But it got the job done, and it got it done much faster than it would have done on a single machine.
So Jacob, there's a couple questions in the chat about like, well, how does this work on HPC machines, for example? I wonder if you could maybe briefly point us at the Dask documentation and just sort of like in a couple minutes talk about all the things people can do. Then maybe if you have a chance, maybe talk a little bit about Dask SSH.
Yeah, sure.
Something that we learned when doing a survey is that the kind of like ad hoc thing that Jacob just did of using SSH to start up Dask was surprisingly common. I think it was the most common way people deployed Dask. And so because of that survey, we then ended up making a tool, Dask SSH, which automates the process that Jacob just went through. Yeah,
absolutely. So this is dask.org, right? This is like the landing page where you can find all the documentation and things to the main Dask project. One of the things you can find is there's this setup tab from the top of the documentation, which has some examples of how to set up locally, how to set up in the cloud, how to set up on HPC systems, Kubernetes, Yarn with Hadoop, or whatever you have. So if the question was about HPC, you can click through this. This will take us through to like an overview of deployment on HPC, and this gives us some information about the different projects that we have that can support different things. So we have the main one that I have the most experience with is a library called Dask Job Queue. And this allows you to use cluster managers like the local cluster we talked about before and the SSH cluster that we'll talk about in a minute. It gives you cluster managers for PBS, LSF, SGE, I think there's a few others in there. And this allows you to do something like this example code here. You import a cluster manager, and then you request a PBS cluster object, right? This will, you give it out the resources you want. You say, I want 36 cores, I want this much memory. Maybe you have queues and projects and things that are, your resources are built back to you. This will be like cluster managers. This will be job queue specific, right? So Slurm may have a different way of specifying this than PBS, for example. You may need to set the wall time and things. These are all options that you probably, if you're used to submitting things to those systems via some kind of bash script interface, if you use like srun or something like that, qsub, you tend to write a bash script, you put some stuff in a comment at the top that kind of configures that job, and then you submit it to the batch scheduler. This kind of handles all of that for you. This instantiating this cluster class generates some scripts with these arguments that you've given in. It will submit those scripts to the whatever you have configured on your local machine, and it'll get you to the point where you have those resources. And so you can call cluster.scale, and that will request 100 workers in that cluster. And you have to set, you have to wait then for that infrastructure to provide you with those resources. But once you have them, you can then start working on things. You can also, I think, scale is non-blocking right at the moment, so you can call scale and then you can start doing things. And as you get more resources, things will just get faster and faster.
Yeah, great. Yeah. So only a few minutes left. Do you want to sort of show Dask SSH?
Yeah, sure, definitely. So all of this that we kind of set up by hand here, what I was kind of coming to is I'm gonna, let me drop out of here. Yes. I'm just gonna kill everything here. Just close out all my servers. Yep. So if I
and while you're doing that, we have a question from Draw around if the if random doesn't persist, will subsequent calls generate the same random sample, and if workers, what happens if workers join between computes?
I'll handle that. Well, Jacob.
Yeah, go for it.
Yeah, everything will be fine. This is a short answer. So Dask tries very hard to give you the same behavior regardless of the hardware or failures. With random, we generate random seeds and then distribute those seeds in like a way that random number people seem to be comfortable with. There's a lot of like interesting things about random number generation. And Dask is fully, so if we'll generate the same block of random numbers if we have to recompute the same task. And as a result, workers can come and go and things will be just fine. So if if Jacob were then to add, a fleet of Raspberry Pis onto his home network, we were early on this process. We were like, he was holding a bag of Raspberry Pis. He didn't quite have time to install, but we can then add all of those too. That would work just fine.
Yeah, it would have been fun to do this. I couldn't actually find a micro SD card adapter. That was my main sticking point there. But I just want to show here, is we've got this SSH cluster. What I did before is I SSH'd into various machines, right, and set things up. So I started a scheduler and I started 2 workers. So with this cluster manager, I can say, SSH to these machines, and you give it a list. So let's say localhost. I'll explain what this is doing in a second, right? Localhost, and then my it was 10.51.0.32, something like that. 32. So what this is saying is SSH to localhost, SSH to localhost, and SSH to this other machine. An SSH cluster will use the first one as the scheduler, and then all of the rest as workers. So what I'm saying here is, SSH to just the machine I'm on now to start up a scheduler, SSH also here to start up a worker, and then also SSH to this other machine. But this list could be as long as you like, and it will pull these together. Now, oh, that's a shame. Let me quickly pip install that.
When it's crunch time, you switch from Conda to pip. I see how it is.
Yes, I do. So things go faster.
I'm curious to see if it finds the right Python executable.
It probably will not. And also, it's likely that I have a different username on these 2 machines. So it's not necessarily going to find this. And I think this is common in many institutions, right? You might have a laptop with one username, and then maybe your HPC username is a different one, right? I remember that specifically. In my old organization, my HPC username was the same as my other one, except it had a number on the end, right? Because for some reason. So if I
so we are at time. So let's take a few more minutes. Let's wrap up.
So I think Dask SSH does actually have an ability to specify like a YAML file or something that you can give lots of keyword arguments to. But I think in general, this shows up, this demonstrates another challenge, which is authentication, right? So you get a permission denied error, like Dask doesn't necessarily, your other machine is not accepting your connection because it doesn't trust you based on how you set things up. As this is another challenge that we run into when we're trying to deploy things, here locally on a bunch of ad hoc machines. We have the same challenge when we're using Kubernetes or anything else. I think that Jacob's situation is particularly challenging because he's using different kinds of machines. He's going to specify the username, but did that work? It looks like it didn't work.
It looks like it didn't work, yeah.
I wonder if the username will work on one machine, but not on the other machine. Like they'll try to send the same keyword arguments to both machines. Anyway, this is the kind of stuff that people run into when they try to deploy Dask manually. You can get it to work. It usually takes about an hour, which is our experience here. But there are lots of sort of other considerations that come into play. And so this is what Jacob and folks like Jacob solve every day.
Yeah, exactly. I feel like we're at time. I could keep prodding around with the SSH cluster. But what I might actually do, just to kind of show it in action, is I'm just going to drop the second machine from the list. So if I instantiate this cluster, okay, maybe it is the fact that I had done that.
And I do want to, we have a question from Gary News. We didn't get to Gary News' first question. And so I'd like to answer this one. How distributed data? So Gary News says some gigabytes of binary, not text, between nodes. How to distribute data between nodes to get benefits of disk speeds of each node.
So I think generally in these situations, you're going to need to have data accessible from everywhere for the most part to be able to get like a reliable computation. Having some kind of network storage, or if you're in the cloud, you may be storing stuff in like a network NFS or maybe in an object store or something like that, so that any machine can pull any bit of data at any time is going to be a best bet. So probably if I was going to set something up at home, I'd put data on my NAS, which is a little server that I have running for storing stuff on, and then probably other machines pulling from that. You are going to then start able to juggle, how fast is the NAS and how fast can I read data off? HPCs have these same problems, right? They tend to have a large piece of storage. Maybe it's a Lustre file system or something. And there are kind of trade-offs, right? Lustre, you have to store very large files. You can't work with very small files because it will, be unhappy in those situations and things. So designing how your data is stored is like a big piece of this. There was some interesting work recently as part of the Pangeo project. There's a library called Rechunker that they created, and that was for taking a data set and restoring it in a way where Dask is going to give you the best performance of operating over that. Because if going back to my experience of weather data, like a supercomputer generating the weather forecast will output a whole globe every hour or something like that, right? You have each file will contain like a single time slice for the whole planet. And so if you want to do, mean over time, that's great. Lots of machines can read lots of files. But if you want to do like a spatial mean, you're going to get lots of machines reading one file, and that's going to be like the performance is going to be poor. So maybe you need to think about duplicating the data and storing it in a different slicing format to kind of appeal to different operations you're going to do on that. So yeah, Rechunker is a tool that some of the Pangeo folks put together for doing that for you.
Great, thank you. And Draw has just mentioned his server is running, maybe restart IPython.
Yeah, I just spotted that. I'm just gonna have a
go. And while you're doing that, I would not be doing my due diligence, and I'd need to fire myself if I didn't mention that a lot of the problems that we're seeing today, and a lot of the work that happens here is something we try to abstract over at Coiled with the product that we're working on. And it's currently a free product that we'd love to get you involved in. So you can sign up for our beta at coiled.io, which among other things are hosted Dask deployments. So I'd be really excited to have conversations with you around whether this solves some of your pain points in scaling your data science work. Is that a fair enough summary, Matt?
That sounds great. And to a certain extent, Jacob, this has been a great advertisement for Coiled, or for managed systems generally, because managing this stuff, while hypothetically quite easy and clean, always ends up being a slightly more complicated than you expect it to be.
Yeah,
and it's
absolutely.
So nice. Just type in, import Coiled or import, Dask Kubernetes, whatever, and have everything just work magically.
Yeah, exactly. I was hoping this would be a good example of here's how clusters work, but clusters are finicky, and it's nice to have something at a higher abstraction to kind of worry about that for you.
What ended up being actually a great example, I think, of when things go wrong and how to diagnose that, right? We saw using things like ping to verify we can actually do connections. We also saw things like reversing the order of the relationship to make sure that connection was bidirectional. We saw things like checking versions and making sure that they are actually correct, even if you think that they're correct. Many times people raise issues and say, hey, look, things are broken. We say, check your versions. They say, I've checked them, they're fine. We say, check again. Turns out they're not fine. We also saw things like Dask SSH or like Dask Job Queue, which automates some of this, but assumes some uniformity. So I think that this has been sort of a good example in how to diagnose connectivity issues, which I think is often the first step, or as you said, the 0th step.
Yeah, definitely. So I think the point that I've got to with this SSH cluster is that it is now trying to find Python in the same place that it is here on this machine. Is assuming that Python is at the same path. And because I'm on a Mac and I'm on a Linux machine, those paths are not lining up. We currently don't actually, I think, have a way of specifying that. So maybe that would be a nice pull request to put into SSH cluster.
Great. Okay, shall we call it a day?
Yeah, and I just want to thank Jacob once again for a wonderful session today. And thank you all for joining.
Yeah, thank you all for coming.
All right, see you everyone.